Good morning, Prof and class. So today, Wende and I will be covering the topic on graph coloring. So what exactly is graph coloring? Graph coloring problem is to assign colors to certain elements of a graph subject to certain constraints. And there are two types of coloring method. The first one is called vertex coloring. Vertex coloring is the most common graph coloring problem. So the problem is given m colors, find a way of coloring the vertices of a graph such that no two adjacent vertices are colored using the same color. And the other one is edge coloring. So similar to vertex coloring, we color the edge instead of the vertex. And there's this terminology called chromatic number. So what does it mean? It means that it's the smallest number of colors needed to color a graph G. And this number is called chromatic number. So for example, you can see in this graph, the minimum color is 3. Yeah, so take this graph G as example. So V is the vertex set. You can see is V1 to V10. And then the edge is V1, V2, V2, V3, and etc. So now we need to color the vertices of the graph so that no two adjacent vertices are allocated the same color, and we want to minimize the number of color used. However, this problem is called NP complete and NP hard, and I think we are going to cover this topic soon after our show and tell. So basically what these two phrases mean is that there's currently no known algorithm that can solve every graph in polynomial time, but in exponential or factorial time. And we can only get the optimal solution by approximation, randomization, and other heuristics. And there is famous four-color theorem. So it means for every map we see, all the countries can be converted into a vertex, and then its neighbors can be converted into edges. So for every map can be simplified into a planar graph. And a planar graph is a graph that can be untangled so that no two edges are overlapping. And this theorem basically asserts that all maps are four colorable. So we can use 4 colors to color every map you can find in the world. Yeah, and this theorem is only proven in 1976. It's the first kind of mathematical problem that got proven using a computer. Yeah, and since we cannot find the optimal solutions using a known algorithm, one of the best algorithm you can use is called greedy algorithm. So the step is basically first one to order the nodes in the graph in descending order with the most neighbors in front and the least numbers of nodes in the back. And then for each node, check the colors of its neighbor and then mark these colors as unavailable. And then we use the lowest available color to color that particular node. Yeah, and that's the greedy algorithm. And then the application.
So there are some applications in real life for graph coloring problems. So one is Sudoku Puzzles, this task scheduling and timetable scheduling. Okay, so I go to the first one. So for Sudoku Puzzle, so basically in a 9 by 9 grid, so each number 1 to 9 will appear exactly once in one row, one column, and one 3 by 3 box. So let's take a small example. So this is a 4 by 4 Sudoku puzzle. So there are 16 blank spaces. So we basically number the blank spaces from 1 to 16. So these can be our vertex. So basically we need to add edges to the vertex in a row, in a column, and in a 2 by 2 box. So if you translate this into a graph, into a colored graph, so it will look like this. So you can see that one has age to 2, to 3, to 4, so that's in one row. Then one also has age to 5, 9, and 13, that's in one column. Then it also has one age to 6, so that's in one box. So after we have come up with this colored graph, so we can get the Sudoku puzzle. So each line, row, and column, each column, row, and box will have 1 to 4 appear exactly once. So that's how we can solve the Sudoku puzzle. Okay, for scheduling on taxi, so that's similar to our project. So first from A, so we have bookings ordered with its starting and ending point. So the first point is the starting point, and the other dot is the ending point. So we ordered with its with time. So we can see, okay, let's say for the first booking, we see is overlapping bookings. So basically 2, 3, and 4 are overlapped. The time are overlapped. So we make that into a graph. So bookings are vertexes. Then we add edges to the overlap bookings. So we come up with the second graph. We came up with the colored graph, which is in B. Then for each color, the red color will be can be assigned to taxi 1. Then yellow can be assigned to taxi 2, and the blue can be assigned to taxi 3. So this is also known as interval graphs. Yeah. So for the third application is actually lecture or exam timetable scheduling. So if you are a teacher, you want to make sure that you want to minimize the time slots, so you can accommodate to more classes in one particular time slot. So let's say for the first is algebra, so it clashes with maybe probability theory, graph theory, and French literature. So each of the clashing lectures will be will add an edge to the vertex. So same thing as we have covered before. So each color will be represented as one time slot. So vertexes of the same color will be accommodated into one time slot. So we can have a minimum of 4 time slots to accommodate 9 classes with different schedule. Yeah, that's all. Thank you.
Any questions for them? So does it matter whether your graph is directed or not?
I think it's only directed. Is it undirected?
Undirected.
Yeah, it's undirected.
All right, thank you.